Hello everyone, welcome to the Promise of Deep Tech Smart Farming from Indoor to Ocean, jointly presented by SGInnovate and A StartCentral. My name is Benny, I'm the Assistant Director here of Venture Investing at SGInnovate, and I'll be your moderator for today's session. For those who are not familiar to us or of us, we are a government-owned organization here in Singapore with the mission to build deep tech innovations from Singapore for the world. We invest in and help build deep tech startups in fields such as artificial intelligence, medtech, quantum tech, and agri-food. We work with entrepreneurial scientists and clinicians to help bring their innovative research from lab to market, and we also develop deep tech talent and engage with vibrant deep tech startups in the ecosystem. With a vibrant deep tech community, a robust talent pool, enterprising investments, as well as commercialization of research with potential promise, Singapore is well positioned to become a leading deep tech hub in the world. The Promise of Deep Tech series hopes to highlight innovative research and technologies in Singapore's growing deep tech scene. Sustainability and agri-food are core interests of SGInnovate, and we believe bold application of deep tech has the potential to ensure a sustainable and livable future for the planet in the face of urgent humanitarian and environmental challenges. Today, we are pleased to have Ong Kian Su, Principal Specialist at the Institute of Materials Research and Engineering at A STAR, and Joyce, Marine Scientist at Umitron, Singapore, to share with us on sustainable farming practices. Kian Su will be sharing on his project about saving energy through sustainable hybrid lighting system, and Joyce will be sharing on sustainable aquaculture with Umitron. This will be followed by a short panel discussion with Q&A with the audience, so feel free to put in your questions in the Q&A box at the bottom of your screen. Without any more further ado, let's invite Kian Su to share more about his project. Kian Su, please.
Thank you, Benny, for the. Let me share the screen. Today, I would like to talk about some of the work that we've done in our institutes regarding energy saving solution for by making a hybrid lighting this system. Okay, basically what we've done is that we have three different approach where we actually looking into the sunlight manipulation solution. That means that we are working with natural lights, and we see how we can maximize the use of natural light. And this particular useful in like greenhouses, but we also will extend the interest into indoor farm, because if the indoor farm can use some of the natural light, but it's plenty in Singapore, they can actually reduce the energy consumption by switching off the artificial lightings, right? And in another approach, we are actually looking into LEDs, where we are actually putting a color filter, color converter onto the LED, and we are able to so-called convert a blue light into other like green and yellow light, which it may need by certain plant scientists or certain type of crop growth, where they are looking into generating some endochemicals that are useful for their productions. So then we also looking into how can we cool down the LEDs and also the environmental by thermoelectric modules, that we are able to precisely control and reduce the temperature of a specific area or specific location of the indoor farm or the greenhouses. And then we are also looking into simulations and also modeling of these lights, sun's directions, and also by doing that, we are able to help the farmer to build their farm or arranging their racks so that they can optimize their efficiency of getting the right sunlight at the right time. And we also looking into how this lighting recipe, such as different wavelength effect on the plant growth. So by doing that, we are able to know when should we turn on the LED, or which type of wavelength we should use during the different stage of plant growth. So by doing that, we are able to reduce the energy used in the lighting because you don't need to turn everything on. And that will actually save quite a lot of energy, because most of the indoor farm turn on the LED for more than 12 hours sometimes in order to maximize the growth. And we also looking into how can we make the lighting more uniform intensity. So when the light intensity uniform, the plant can grow in a more regular way and not some, for instance, different size of leaf and things like that. So that will make the packaging and also consumer more likely to take up the products later in the market. So, and also we are able to reduce the distance between the lighting and also the plant, so that you can put more racks within the same area of prints. And more importantly, we want to create a plant library and also a plant growth model. So this will add on so that we are able to predict how the plant can grow with the different setup, different lighting recipe, or even different genetic histories. So by doing that, the farmer are able to grow the plant in the most economical way and more sustainable way. So this is the overview, and everything when they add on, we are target to save 40 to 80% of energy consumption on lighting. Okay, let me select some of the products that we are developing now. So one of them is a quantum dot color converter. In this case, we are, if you look at the bottom part, this is the industry so-called lighting recipes that we capture. And on this area, the next one is actually after we talk about quantum dot color converter, you can see that we actually can maximize the green region. And this will allow, you can also change the different type of filter, color converter. We are able to shift this green to orange or even to red. So in this case, you can imagine that the farmer just need one color of LED. They don't need to have all different LED array. That will make their cost of LED even lower. And the farmer can actually control what are the wavelength or spectrum that they need for the particular type of plant they are growing. So this is particularly useful for fruity products like strawberry, tomato, all this, because they have the different growth cycle that require different type of range of this light spectrum. Yeah, for DV green, I think they basically red and blue can do the job, but at different stage of the growth of this DV green, they also require different level of red and blue spectrum. So with this color filter, we are able to mechanically match well with the needs of the plant, and then you will help to improve the plant yield, and also at the end, you save energy by not turning on unnecessary or unwanted LED diodes. All right, so we can actually make up to a A4 size at the moment, and we are openly looking at company or any interested party that can work together for further development of these products. I have a video at the bottom right, just to show you how it works. Yeah, so the first two is actually just a normal color filter. You can see that the light does not change, but when you go to our color converter, you can see that the white light actually turn into the color that we want. So by having mixing and of all the different type of QD material within the film and matching with the LED, we are able to create a nice spectrum or a working spectrum that the plant scientist or the farmer need. Okay, for the TE thermoelectric material, we already have the product that are able to reduce the temperature from various level. For instance, if the farmer required to reduce the LED panel from 30 degree to 25 degree, we will tailor make the cooling material and the cooling module so that they are allowed, because we will not want to have a over correction of temperature. If we cool the temperature too low, it will actually affect the plant and also induce water condensation that is not allowed in the whether it's in the greenhouse or in the indoor farming. So by doing that, we are actually looking into we are just patenting and looking into how can we save energy and by cooling the indoor these greenhouses in the description here. So we are able to reduce the temperature and maintain suitable temperature inside the growing environment, so that the plant can grow in a healthy way, because the temperature will affect the plant growth. And also, if the temperature is too high in the greenhouse, you need additional fans and also cooling to reduce the temperature and to maintain the temperature inside the greenhouse. And this will actually add a lot of energy consumption to the greenhouses. All right. Another research area that we do is actually we are achieving a very uniform so-called LED light intensity. So this is a conventional one, and you can see that from the measurement, from the center to the edge, the LED intensity varies a lot, and it's up to uniformity is only up to 0.45, which means that the average intensity over the higher intensity. So which means that a lot of energy is also wasted, because some area is overheat and overexposed, and some area is underexposed. Imagine if you put the plant 4 or 5 or a row of plant in this area, some plant will grow faster, some plant will grow slower. And at the end, that will affect the ultimate production output and yield, because certain plant overgrow, undergrow will not go to the market actually. Right. So we are able to make it uniform, and by doing that, wherever you put your plant, whether small pot, big pot, you are able to place them in a way that is more cost economy, and actually reduce the restriction of only can put the plant, they say, or only at a certain area, and avoid the hotter and the cooler, higher intensity and lower intensity area. And another advantage is we are able to reduce the distance between the plant and the crops. So this type of product that we develop, actually also aiming at higher value plants like microgreen, and that way they do not require a very wide space between the plant and the lighting source. But however, the existing so-called lighting system is only tubes, and the intensity is fixed. Okay, so this comes to the most important thing for today's talk. It is actually our sister RI that developed all these simulations and recipes. So what we want to do is we can actually help the farmer to design their indoor farm setup or their greenhouse setup. We use a word called feng shui. We are able to see where the sun comes from. From this, we can know where is the sun come from. From morning to morning to afternoon, or January, February, March. We are able to detect and model, and also to actually simulate the different angle of sun. So this is very useful for farmers when they want to set up their farms, or they want to actually improve their farms infrastructures. And we also able to model the light in moving a different this so-called medium, and from there we are able to see how the light actually move from one surface to another surface, and also how they can reach the plant. Right. So this is some of the data that we have, and you can see that we can be so our simulation can even go right to hours or the particular day or particular month, and then from there we are able to compare with the meteorology records, and we found that we are quite accurate with our simulation models. So we can use it for, okay, you want in 2023, what will be the sun distribution look like in month of July or something like that. We are able to actually predict them. All right. So this is another example that we are doing on the particular dates. Right. And this plant growth simulation is still in the developing stage, and we need help from farmer because we need more data input that, for instance, certain plant will not leave, not all the plant will grow in this orientation. Some plant will grow in cross, some is twisting around their leaf and all this. So when we have more information, we can actually make this simulation much better, and we are very open for collaboration in these aspects. All right. And at the end of the day, we want to have we are developing a plant library that we have all these plant growth data, plant recipes, spectrum use, and also nutrients and all sorts of information that is useful for plant growth. And then what we do is we will convert it, we will make it into a library, and then we are able to use the AI platform, and then we merge with the simulation of the plant growth. We are able to let the company or the farmer know that what is the best setup that you can have, what is the best so-called environmental control parameter that you should look for at the different stage of plant growth. And then from there, you are able to grow your plant in a controlled environment, controlled condition, controlled manner. And this will help us to reduce the amount of light energy used in the lighting, and also reduce the waste of nutrients, and also make the plant growth cycle even shorter, and that you can allow higher yield and also higher output. Okay, so this is my end of my talk, and this is some of our team members that are working on of the different projects. And I'd like to thank IMRE IPP for the funding, and A STAR and IPC colleagues for helping in these projects. And I can be contactable in this email, and I think the organizer also have this email that you can contact me anytime if you need. All right, thank you very much.
Thank you, Kian. So maybe we will now shift gears a little bit and invite Joyce to also share Umitron.
Yeah. Joyce, please let me go off first.
No worries, Kinsu. Thanks very much. So just give me a moment to share my screen. All right, so time to take a deep dive from Earth to ocean. Hi, everyone. I'm Joyce. I'm a marine scientist working with Umitron. So we are a software-centric deep tech company based in Singapore and Japan, and we're aiming to solve worldwide food and environmental problems using technology. And in particular, we want to empower the aquaculture industry, and we want to help the community to overcome challenges and to grow and to develop in a productive and sustainable way. So our story starts in space, where our founders were armed with aerospace and software engineering experience. We're looking for potential areas where they could leverage their knowledge to solve critical issues. About half of our team is made up of software engineers, they're over here. But as you can see, our combined technical expertise really spans across multiple disciplines. So we often get the question, why aquaculture? And our answer is always, why not? With an increasing global population, rising affluence, a higher demand for better quality food, particularly in the middle classes, and increased access to technology, the way that we produce our food, particularly protein, will need to adapt to the changing times. And coupled with the uncertainty stemming from COVID-19 over the past year, that need for technology integration in the way we produce seafood is higher than ever. New advances in satellite technology and data analytics also means that there was this massive potential for us to make this big impact in the aquaculture space. So let's now zoom in on the good stuff, what we've actually been up to during this time. Over the past few years, we've been developing an AI algorithm called the Fish Appetite Index, FAI, which is integrated with many of our products. It's capable of detecting hunger levels based on fish feeding activity, and it provides farmers with notifications. So you see here some data from the sea bream farmers that we're working with in Japan. So green shows that fish are very active, they're likely to be hungry. Yellow shows that the fish are starting to become full and farmers are encouraged to stop feeding soon. And red shows that the fish are likely to be already full and feeding should be stopped altogether. At present, FAI is working as a guidance system for farmers to take necessary action. However, but given enough supervised data, we do believe that this system will be 100% automated in the future. And in many cases, we did find that the producers we were talking to did not have the proper hardware, or sometimes they didn't even have any hardware in order to utilize our software. So to fill that gap, we created Umitron Cell and I. Both devices use a combination of edge and cloud computing coupled with FAI to help farmers with feed optimization. We also have Lens. It's a portable piece of equipment that farmers can use to determine exactly how much fish they're growing in real time. It works using stereo cameras to identify key visual markers on fish that can be used later on in length-weight correlations depending on the species, and that will result in a final biomass value. So over here, you can see a snapshot of some of the active projects that we're working on right now. You'll notice also the team has started a joint project with CP Foods in Thailand, and that's aiming to use our AI and automation technology to develop a future sustainable model for super intensive shrimp aquaculture. So all those like wontons and things that you see in the supermarket likely comes as a result of the technology that we use. A lot of what we do in the past actually involves traveling a lot. We travel to farms, we talk to people on the ground, we assess what challenges they have, and then we go back to our proverbial toolbox and we see what sort of solutions we can best recommend to help these farmers solve their problems. And this is particularly important when we have a hardware component and we need to make sure that everything is installed and tested correctly before we really let it run full swing. So as you can imagine, the global onset of COVID-19 did slow us down somewhat in that regard. But that being said, it didn't stop us. We quickly shifted our focus to developing new software products so that we could continue working remotely from home, continue developing software solutions that could help farmers. It also lets us continue wearing comfy pants on Zoom calls like this one. But most importantly, it ensures that our team members stay safe until such time when the pandemic situation improves. In July last year, we launched Umitron Pulse. What it is essentially a satellite-based ocean monitoring service, allowing farmers to access real-time, high-resolution data worldwide from anywhere in the world. So we've got 5 key parameters: dissolved oxygen, temperature, chlorophyll, salinity, and wave height. And this is what's currently available. And best of all, the basic plan that we've created is free for anybody to use. So you don't really need to look at a big investment for it. We're still looking to integrate new environmental data in future updates, and we'll still be continuously rolling out new features to make this service more accessible and user-friendly based on user feedback. And for maximum convenience on the go, Pulse is actually available on both desktop browsers and for Android and iOS devices. Towards the end of 2020, we also released Remora, which, as its namesake suggests, lets us integrate our software with a farm's existing hardware, such as their camera systems. So this lets the farmer not only monitor feeding behavior, but also feed wastage, without having that need to consider, oh, I need to buy a whole new set of hardware just to use the software. But naturally, when the COVID situation improves, we will pick up where we left off before COVID hit, and we'll start reaching out again to farmers who do need products such as Cell, I, and Lens. So at this point, I would like to take a step away from talking about just technology and talk a little bit about Umitasati. It's this initiative that we launched towards the end of last year, and we really want to advocate for stakeholders along the value chain to be more emotionally in touch with the way that we produce our seafood. And that aim is to generate awareness about sustainable seafood production and for consumers to be more involved in the future of our oceans via their seafood choices. At the same time, we're also hoping to encourage farmers to consider that technology adoption isn't just an operational need, but it's an environmentally centric one. So we've also partnered with ASC, the Aquaculture Stewardship Council. They've come on board to partner with us using their education arm to help spread that message across the world that you need to choose sustainably produced fish for the future of ocean protection. We started this initiative in Japan in collaboration with Chefs for the Blue. They are an advocacy group comprising like top Michelin chefs across the country. They actually work together to raise consumer awareness about sustainable seafood. We've also partnered with Daisuke Igarashi-san. So he's famous in Japan for his manga and the movie Children of the Sea. And he's created stunning visuals like the one you see on the right and behind me to help us promote the idea that aquaculture doesn't just have to be a business. It considers a bigger picture. It considers the environment. And now moving forwards, with that initial success, we're on the lookout now for suitable partners to roll out Umitosachi globally. And really, we're still not done, and I don't think we'll ever be done. We will continue to keep innovating. We want to continue pushing our limits to create technology that will service the entire aquaculture value chain. And ultimately, we want to achieve that mission that we have to install sustainable aquaculture on Earth. Thank you very much. And Benny, I think back to you.
Yeah, thank you so much, Joyce. And thank you as well to Kian for your sharing. I think the audience has learned quite a bit about both your system, Kian, as well as the work that you do at Umitron, Joyce. So if I can now invite both you, Joyce and Kian to join us at this panel. I'd like to remind the audience at this time that you can post your questions to us at the Q&A. I will be the moderator. Unfortunately, I'm not as qualified to answer questions as our two distinguished panelists, but I'll help to redirect your questions to them. I already see two questions up here, but before I get into those, maybe I'd like to start with a sort of a general question to both of you. You're looking at systems to help and deep tech systems that to help with aquaculture and agriculture. But in your dealings with farmers, whether it's in aquaculture or agriculture, what are some of the challenges that you have faced in convincing them or coaxing them into trying out the solutions and giving it a shot? Maybe we can start with you, Joyce. I think you mentioned some of these potential challenges in your presentation, but if you could share a bit more, I think that would be helpful for the audience as well. Thank you.
Sure. I think many of the farmers that we've spoken to who don't really utilize a lot of tech are convinced of that, saying that you can't teach an old dog new tricks. You know, we've seen that most of them are very motivated to help their farm grow, but they're not really sure if technology is that missing piece that will get them to the end point. And for many of them, new technology adoption usually equals expensive, right? A lot of concern from that angle is that, you know, if I add something new to my farm, I'm going to have to scrap everything I have right now. It's going to be a significant investment from the ground up, but that's not necessarily the case.
Okay, so the focus on incremental change rather than a revolution is probably key in convincing farmers. Okay, great point. Kian, so what about yourself? In your experience, what have been some of the challenges in speaking to farmers or getting people to test your solution?
I think it's the cost. Yeah, it's a cost and the time schedule, because a lot of farmers, they are actually very tight with the financing, and also they have a very high demand on their present production outputs. So when we approach them, they will say, okay, how fast you can make the change? And if you make the change, how fast can we get the returns? And that's a very, I think, practical questions that they ask. And that's why I always encourage them, well, we should talk in advance and understand their setups. And also then we can actually do some simulation modeling, and then we can go back to them and say, look, if you do this, you can continue your present production, and yet you can actually get the certain area to do the test up of the our technology, because that will help them to gain the confidence. And any changes, any new adoption of technology, it's not necessary you must tear down your buildings, you can actually look into the flexibility and also the opportunity to add on to the existing infrastructures. So this is actually case to case and depend how old or how new the farm is. So I think that is something that we look at. Even I think for fish farm is the same. Some of them say this fish farm is already from my grandfather to now. It's actually, I don't want to change anything. They will tell you that. And then I'm doing well, why should I change? So this type of question will come back, and I think we need to convince them by having our product and encourage them to validate it in a smaller scale before they actually adopt the new technology or product in a larger scale. And then that time the costing, the ROI, etc. will come in. Yeah.
I see. So I think in some ways it echoes what Joyce mentioned about not having to tear everything down. Incremental change is probably the best approach. But if I might just be able to put you on the spot here a little bit, you mentioned about cost. So is there a certain guide to the cost involved for your system at this point in time? I'm sure every project is different, but is there a guide to say, in implementing the system, it would cost, X dollars? What kind of ROI that would you then expect for any given project?
So lady first. Joyce, are you want to answer this question, or you want me to go ahead?
You can go ahead first.
Okay, I think Joyce, the product is more ready. She knows the cost much better than me. For me, some product in the development stage or research stage. I think cost is varies depending on the skills or implementations. And it's also in terms of the economy of production. If they say a big farm and they need a higher quantity, then we can reach the scale of economy. So I will say that definitely there's the cost. And my approach is we will look in the cost, and then we look into the saving in energy immediately. So if I can save 30% of energy, I think any cost become minority. And then from there, and also from the yield and all this. So, but all this we have to convince the farmer that from the lab, this is the cost we have. And then from there, I think cost is a bit sensitive, so I can't give you the value, but the figure, but it depends on product to product. The quantum dot material, in fact, the cost of the per panel, it will be surprisingly cheap. It's cheaper than the filter, I can tell you that. Okay, so the color converter, the amount of quantum dot material that we put in is also depending on what are the end user needs. So it actually can go down to a few cents per square meter.
I see. Just before Joyce answers, I think I saw an interesting comment here which says that in terms of costing and pricing for farms, maybe it's better to use first and let them pay later. What is your take on that, Joyce?
Well, we actually do, before we actually implement any project commercially, we actually give the farms a trial period. So that doesn't give, let me rephrase, it doesn't just give them the opportunity to test out our systems, but also gives us a chance to test our systems against a new environment or a new species. So it's not like outright, we're gonna, okay, pay X dollars upfront, because we do acknowledge that any form of AI training and data supervision does need that training and learning period. So we always start with an inception period of a couple of months to a teething period, if you will. So we sort of suss out all the potential problems. And then at that point, we're really comfortable with where things are going, we sort of start discussing a commercial project and that paid plan. But also a lot of what we do is subscription based. So if it's just a software, they don't need to commit for, let's say, 10 years. They can use it if they need it. And then if they feel it's not suitable or need some additional customization, we can price that accordingly. Okay,
understood. And I suppose in the work that both of you do, whether it's in the lab and developing new technologies and trying to commercialize that, or in Joyce, in your case, where the technology is further ahead in the commercialization journey, you have to work with different parties. And in your case, for example, CP Foods, for example, was listed in one of the engagements that you do. How do you engage with other organizations, be it corporates or research labs, in your work, and how does that how do these partnerships typically take place?
It involves firstly having a very thick skin. I think, as you know, the aquaculture industry is really, really niche. So there are very few industry players and everyone sort of knows everyone. So you have to really be, firstly, very confident in your product and where it's headed for the future. And you have to be very tenacious in getting connections. The good thing is that the industry is very open to introduction. So they're very happy to talk to you, to listen to what you have to say. But the proof is in the pudding, right? You really need to showcase that your technology has results. And I think what we've done is proof of that. And in turn, people like CP Foods took a punt with us. They said, I know your shrimp technology is not as developed, but we believe that what you've done with fish so far is proof that we're able to develop something cool with you for shrimp. So we've sort of adopted that approach with more than one partner. And in Japan, we're actually working with multiple government agencies as well. Yeah, across different prefectures. Yeah.
Okay, and Kian, so in your experience, what is it like partnering with others from an A STAR perspective?
Yeah, first thing is the cost. So most of farmers told me, if they don't have to pay a single cent, they can do anything together. But I think that is not the right approach. That I would explain to them that A STAR also taking so-called a step ahead to develop technologies, and in like what Joyce said, we are willing to test bait or even validation with the farmer. And once they found that it's good, then I think they can think about what is the scale of implementations or adoptions. So at that time, we can sit down and then we have to do all the costings and detailed considerations. But I think first thing is we must have the workable products, and they can feel it, they can touch it, they can use it. Then that will actually help to engage the farmers and bring them closer to the technology and not sticking to the old practice or those are the so-called non-productive practices. So it's always not an easy thing to understand the power of the technology. For instance, the Joyce, the feeding system, they say, no need, I just ask my worker, they know when to feed the fish. And we know when to harvest, but they didn't know that, in fact, if you have a good system, you not even need the person to walk around and feed the fish and things like that. So once they know it and they know that the power of technology, and I think they will be the first raise of the two hands and say, please give it to me. So I think we are very optimistic on these aspects for adoptions.
Sure. Okay.
Just following up from Kinsu's comment about, I totally agree with what he says. Farmers will think, oh, I've got a worker here, they could do whatever technology can. But we've actually noticed during COVID, if people can't go to work, that is a problem. So technology is able to sort of temporarily or even offer some sort of relief for industries that have a manpower restriction in place, and they can continue production as per normal, maybe just use a limited manpower resource for harvesting or grading, but the actual feeding process itself and disease mitigation doesn't have to be manpower focused. Yeah,
I even tell them that, in fact, don't worry about the cost of the automations and using of the digital technology, because Singapore government encourage everyone to do that. We can help you to find some good agency to talk to them. But I think first of all, we need to let them step up first, and then we need to try and look into the new technology. And in my slide, I think I put a lot of effort on AI modeling. You can just imagine if the farmer need to tear everything now just to try something. I don't think anybody would do that. But when after talking to them, we can actually simulate a model for them and say, look, this is the result if you test something now or you change it. And then that would, I think, very, very convincing for them to try. Yeah, and we can avoid a lot of unnecessary hiccup and side effect of the technology adoptions.
Okay. Great answers, and I love the fact that both of you are jumping in as well. So let's keep that going. I like this.
Share the same feeling.
Yeah, I like this tempo. So let's keep it going. But I think Kian, you mentioned quite a bit about having the farmers understand also the technical aspects, and we are seeing a couple of questions come in on the technical aspects of your solution. So maybe we will stick with you just for a short bit to ask some of these questions. So I think the first from Timothy was about the difference between different crops. So on some of your slides, you talked about different times, different seasons. But how does it take into account the application of light for different crops? What sort of information sources do you use to decide?
Yes. So for different crops, even the same, let's say, same so-called class, that lettuce, or you talk about gailan, chai sim, or bok choy, they still have a lot of subspecies. I think fish also the same. So all the species have their genetic, this so-called property. I use the word property, but means that they are some of them are more susceptible of certain changes in the spectrum recipe, but some may not. Some species may respond to more higher intensity, but some may just ignore the higher intensity and go to sleep. So this is something that the farmer need to know, and then after they know, then they can formulate the recipe for the lighting. And then at the different stage of the plant growth, and the different species will require different consideration and attention of the light recipe. While we're doing it so precisely, only it can be achieved by AI automations and things like that. I mean, that is only, we cannot have so many people stand there and look at the plant, right? So the actual thing is you have to have a modern factory like of operation, that the sensor is there and they monitor the plant grow. At the same time, what is the chemical build up in the plant, whether at the right stage. And then all this feedback to the system. And then we are able to adjust the recipe according to the plant size. So I am not a plant scientist, but this is what I can share with you, that it definitely different plant and grow differently. But same species, it depends on the quality of your seeds. If your seed is 95% similarity, then of course you may have 5% fallout. So that is no choice, even for the same species. So they say that let us know that farmer is not easy task to produce the right products. I think fish is the same.
And a quick follow-up from a question from Vincent. So sometimes when in vertical farms and indoor farms, we look at growing crops that we don't typically grow in Singapore, such as kale, right?
Yep.
So how do we then, is it necessary to simulate the sunlight conditions for where those plants are normally grown? And if so, what kind of, how do you know which geographic locations to draw your info from? Yeah.
Okay, for Singapore, it's quite small. I think our colleagues are able to simulate, as well as tell the coordinates, we are able to find out, and also modeling where is the sun come from and where is the sun set at the particular area that you are interested. And then from there, we actually can build the model and tell you where the sun, the angle, and how should you arrange facing your racks so that you maximize the exposure of sunlight and minimize the shadowing. Because for greenhouses, shadowing is an issue. As you go taller, normally you can see most of the greenhouses is one tier. The reason is if they go for 2 tier, 3 tier, then the bottom one will not grow because they are blocked by the upper neighbors or plants. So by doing, we are trying to address this issue and hope that so that the first in the arrangement of your infrastructures, so that less shading area will be formed. So the distance, spacing, the height. And then the next thing is also we have developed certain lighting transportation panels that are able to reflect partial of the light into the shaded area, because we don't want to divert all the light to the shaded area. Then you are blocking the sunlight that at first it's okay for the plant, and then you're blocking those tier away from the sunlight. So that is quite a tough so-called direction or technology that we are looking at. You need to consider visibility of the light at the upper tier, and then also bringing sufficient light to the bottom tier. So these are the things that we are working on, and we are actually working together with the simulation models, and we are eager to try in the farm, actually.
Okay, got it. Thanks, Kian. So I on that note, on tender living care for crops, switching gears a little bit to Joyce, with aquaculture, we've seen issues around, packing a lot of fish, a lot of shrimp together in a very small location, or issues around waste and pollution. Would you be able to share how Umitron and its products and solutions are able to address some of these issues that arise, or how it works with partners to address some of these issues?
So addressing the problem of waste is not a direct one, but we've historically seen that the reason why waste accumulates is because farmers tend to overfeed. They can't actually, short of putting their head underwater and looking at the fish throughout the entire feeding session, they really can't tell with certainty exactly how hungry the fish are and if they're feeding enough. So as a result of being able to track fish feeding behavior and feeding on a needs-only basis, we're actually reducing the amount of feed wastage in the water column, and that in turn reduces the amount of decomposition that will end up accumulating in the sediment. So I would say it's an indirect answer to solving that waste issue. Farmers that we spoke to and we worked with 3 years ago to now, when we did a sediment sample, we found, oh, actually, there isn't a significant difference between 3 years ago to now, right? After they've started using feed optimization technology. So in that regard, I think whether it's using Umitron's technology or any form of other fish feeding monitoring system, it's going to help with that.
Okay, understood. Also, I just wanted to ask, you're involved in different projects around the world. Is there a difference between the way farmers perceive technology and their willingness to adopt technology here in Singapore compared to farmers overseas? Are there things that farmers in Singapore can learn from counterparts overseas, vice versa?
I think you sort of dropped out a little bit.
Sorry, I'll repeat my question.
Oh, was it the question about Singapore, was it? Differences between?
The differences between Singapore and farmers overseas, yes.
Yeah, I think we're a pretty small country compared to all of our other producer countries, and most of the farms that we see here also operate on a smaller commercial scale. So things like kelong and multi-species style farming certainly isn't something that I see much of outside of Asia. And it's definitely been this challenge to come up with solutions that span this variety of farming. So from that, definitely there's a difference. But other than that, the baseline challenges about addressing feed wastage, monitoring fish behavior, looking at disease down the road in the future, monitoring the environment, those things, the baseline challenges don't change. And the needs for those technology to be integrated largely remain the same. But I think in terms of looking forwards for local farmers, perhaps moving towards more single species focused farming may be more beneficial. From a management perspective, it's going to be better for the farmer. They're able to focus on operations for one species, improve growth rates for only one species, formulate better disease mitigation measures. But I do understand that our current farming landscape is it's a byproduct of our food needs in a local context. So there are certain things that can't be changed in the here and now. So it does ultimately boil down to whether we can find a sweet spot to marry, our technology with the problems here in the local context to make it work. Yep.
Gotcha. So noted, especially a point that the market here is very small. I think we're all quite aware of that. But as we build towards, our 30 by 30 nutritional goal, are there any aspects in Singapore where it's an advantage for us in aquaculture? And I'll ask the same question to Kian later on agriculture. But in terms of aquaculture, are there any advantages that you see in our market that maybe we should try and press home that advantage?
I think the biggest draw here is that we're very tech savvy overall as a country. I can draw a comparison with Japan. Historically, you would think Japan equals high tech, right? But when we spoke to farmers on the ground, they're actually not super evolved. They're still working in very artisanal cages that hasn't changed for maybe 60, 70 years. And they totally have zero concept of technology. Whereas people in Singapore, they know that it exists and that there are avenues to tap into, let's say like funding from the government, private institutions, partnerships that they could explore, but they may not be comfortable enough taking that step forward. So I think this is the key difference why Singapore as a center of excellence could help move the whole region ahead.
Okay, great point. And to Kian, in agriculture, do you see any advantages that we have in our ecosystem compared to others overseas?
First of all, we have a very good government that I think very supportive of our research. And we are open society that we are able to welcome and engage with all the expertise from the world. And in this case, we are able to help us to further accelerate our technology and also to meet with the world market demand. So I believe this is all well known by a lot of bankers, and we have a lot of grants, and also we have a lot of good researchers come from worldwide to Singapore that are able to look into various aspects and various needs outside Singapore and within Singapore.
Okay, thanks for your answer so far. I think I'm going to switch tracks a little bit and get a bit more whimsical. So outside of the work that you guys do in your organizations or the work that your organizations do you see any sort of advances or innovations in agriculture or aquaculture that you find exciting and think is the next big thing that people should be more aware about? Maybe we can start with you, Kian.
Yeah, I think in A STAR, we have a collective effort, which is headed by our A2HTPO, which is a horizontal office. You can see from our website, and Peter is our in charge of the director of the office. And what we do is we actually collecting all the capabilities and also so-called ability that we are working in this food related technology from all our institutes and also partners. And from there, we are able to look into what are the most so-called relevant and technology that we can actually put on and sell and introduce to our farmer. And we are also tie ourselves very much on the 2030, where this is the first most important objective that we need to help to achieve for Singapore. Then once you achieve that, we can talk about how to venture to other countries or how to collaborate with countries beyond Singapore.
Okay, got it. So exciting things coming out of A STAR, and we'll keep an eye on that. Joyce,
Yeah,
what about you?
many things. In fact, including so-called agriculture, then also aquaculture, and also food safety. So we have all together, and any question, any area that you want, we have someone to talk to you.
Okay. And Joyce?
For me, it's actually the offshore automated farms, like the ones really, really far offshore, like Ocean Farm 1 that you would have seen being put up in, built in China and then towed further offshore off the coast of Norway. Yeah, particularly because, land scarcity is, I think, going to be a very big problem for us in the future, given our growing population. So that helps us to set our sights on alternative farming areas that will continue to provide food in a productive and sustainable way. Yeah.
Oh, cool. I should get more into that space as well then. So staying on this note just a little bit, if we were to look at problems in agriculture and aquaculture that haven't been quite solved just yet, what are some of these areas where you think technology can make a difference?
I can go first. So I think most problems that we've seen in aquaculture to date, to be honest, has already been addressed by some form of technology. It just depends on whether the farm has adopted them or not. The real challenge, I think, that needs to be addressed is whether all of these systems that come up from different companies, different people, research institutions, whether they're set up to talk to each other. And very often we find that the farmer will probably get like software A, hardware B, so on and so forth. And the farmer itself has to jump through multiple hoops in order to make sense of the data in a productive way. So that, I think, it's not challenges in aquaculture being addressed per se and helped, but whatever is out there already needs to be more inclusive, and shared amongst more parties. If not, it kind of defeats the purpose of adoption anyway.
And I think this echoes a comment that one of our audience members made about in some way in that there has to be a level of trust and faith and confidence in all of the ecosystem players in working together. Kian, would you want to add to that as well?
Sorry, can you repeat your question again?
Oh, about problems that still exist within agriculture and aquaculture that haven't been quite addressed just yet, but we can use technology to address them. And I think Joyce was going from the angle that it's not so much the technology, but getting people to collaborate together and work together, right? Would you like to add as well to those points?
I think they have two sides, because as a farmer, they also have competitors around. So I think we are the technology provider. Of course, we are naive and want everyone also use our technology. And in farmer or the customer aspect, they'll say, if everyone use your technology, then how can I differentiate or be better from the other farmer? and how can I gain business so-called advantage by adopting your technology? So sorry, I try to go to shift my so-called shoe. I put myself into it. So to answer that question, I think important is tell all the farmer that we have to sometimes competition is good, but sometimes collaboration is even better. So if the more people can adopt a certain technology or product, they make the cost lower, and also make the product evolve to a better so-called performance in a shorter time, and everyone will have the not the equal benefit. In fact, it's depend on the degree of adoption and how smart you adopt it and how far you adopt it. Correct. So it is to tell the farmer, don't get upset or worried that if everyone using the same one, everyone use the Apple computer, right? But I think the revenue generator can be very different from everyone. So it's first step. You must approach. You must willing to try. Then the company will also have expertise to further develop or further improve it possibly, and then that kind of long-term relationship can come in, and that will make you make the company benefit most from this type of so-called new technologies.
Understood. So I suppose both of you kind of agree then that collaboration is key. If I were to put you on the spot right now, what kind of ways can we enhance or foster collaboration in the Singapore ecosystem?
Okay, maybe I can start first. From A STAR, we have many ways. We can have of course, first we sign NDA so that we can discuss more. And then we have a research collaboration agreement. So we have our industrial so-called management, development manager to talk to you, to make you understand, and also whatever costs involved. And we also have Accelerate, which is part under our ENT, this arm that have all the experts to tell you how can you go, and to share with you all the different type of technology that we are having or developing, so that you can choose and match in a better way. So basically, it's a very open system, and we are all reachable. And I think I will say this is to be a case-to-case discussion, one-to-one. And if we find that there is a benefit for many to many, that means we can call everyone in, forming a consortium, and so everyone benefit for that, and that also can be done. So there are many ways. Or we found that there is a need to bring in ESG, to bring in EDB. Then we can always link up, or even our food agency partners that can come in, and that will also possible. So I would say there is many ways and opportunity we can do. As long you can contact one of us, you can reach every one of us.
Excellent point, excellent point. And Joyce, what about you? What's your take on fostering collaboration?
I think I echo the sentiment that Kian said earlier, that everyone's pretty protective of what they have. Oh, if I'm using it and he's using it, doesn't that make us the same? And we've certainly seen instances where a farm said, if you're working with me, you can't work with them, because I want to be special. I want to keep all the data. So I think it really boils down to having a mindset shift. You know, everyone in the industry needs to be more open to sharing information. And the more comprehensive a picture we can build about the industry, the better we can create and refine solutions that the industry will find useful across the board. So it's a collective improvement. And data is great, right? And everyone's collecting data, but what is data without putting meaning to it? If I can't make sense of it and I don't know what it does for my farm, each individual entity collecting data and not pulling them together at shared resources is just useless. It's just taking up space on your Apple hard drive.
Okay, thank you so much for your points today. I note that we are 2 minutes past the hour, so we've actually overrun. We've got a ton of questions to actually go through from the audience, but unfortunately, we don't have the time to go into every single one. So I think we would love to keep all of the conversations going. My colleague Fling has very helpfully put up our email addresses and our LinkedIn profiles. So for everyone in the audience, if you'd like to reach out, feel free to reach out to Kian, to Joyce, and to myself. We'd be happy to carry on these conversations that we've had today. Very enjoyable conversations. Thank you so much, Joyce and Kian, for your sharing today and for joining me on the panel.
I spent some time on answering questions.
Yeah.
I think those questions can pass it to us so that we can actually answer offline. Yeah.
Sure, we'll look into
that. Definitely.
Nice.
Thank you, everyone.
Thank you, everyone.
Thanks, everyone.